We live surrounded by infinite convenience. Everything you could ever want to know, watch, or buy is available in fractions of a second. Yet, for many of us, the default state of existence feels incredibly exhausting. You wake up tired, you struggle to string together an hour of uninterrupted work, and even the smallest tasks feel unusually difficult. The source of this exhaustion lies right behind your forehead, in the prefrontal cortex. This is the brain's executive control center. When you try to toggle between a spreadsheet, an email, and a text message, your brain doesn't actually process these tasks simultaneously. Instead, it forces them into a rigid queue, handling exactly one piece of information at a time. Every time you jump from one task in that queue to the next, you pay a physical toll. Neuroscientists call this the psychological refractory period. It is a literal delay, a fraction of a second where your brain has to disconnect from one neural network and boot up another. You create cognitive friction every single time you switch gears. The human brain puts up with this friction because it is constantly being bribed. Every notification, ping, and new message acts as a tiny novelty signal. Your brain responds to that novelty by releasing a quick hit of dopamine, giving you a rush that mimics the feeling of actual productivity. You feel busy and engaged while clearing your inbox or refreshing a feed, but it leaves you empty. Scrolling through a bottomless timeline requires zero cognitive effort, so it becomes a mindless compulsion. Meanwhile, writing a report, folding laundry, or even just sitting quietly suddenly requires an impossible amount of mental activation energy. Your inability to focus on a single task is not a character flaw. It is not laziness or a lack of discipline. You are paying a higgledy-piggledy tax because the highly engineered environments of modern technology have hijacked the reward hardware you rely on to survive. To understand how that hardware gets hijacked, we have to correct a widespread biological myth. Dopamine is not the chemical of pleasure. It doesn't make you feel satisfied or content. It is the neurological engine of anticipation, craving, and motivation. It is the chemical of wanting things. This chart shows how your brain ideally regulates that motivation. Notice the smooth, continuous wave. This represents your baseline, known as tonic dopamine. It operates like a steady background hum, providing the consistent drive you need to learn complex skills, form long-term memories, and engage in deep work. But the smartphone in your pocket disrupts that baseline. It acts like a digital hypodermic needle, delivering highly concentrated, unpredictable stimuli straight to your visual and auditory cortices. This triggers what are called phasic bursts, massive, unpredictable spikes of dopamine that shock your reward pathway. Your brain is highly sensitive to chemical imbalances, and it protects itself through a process called homeostasis. When the striatum, a key part of your reward circuit, senses this constant flood of chemical spikes, it scrambles to lower the volume and protect your neural circuitry from burning out. It does this by physically changing its own structure. To dampen the noise, neurons in the reward circuit downregulate, meaning they literally delete their own D2 dopamine receptors. They pull them back inside the cell, essentially shutting their doors. At the same time, specific proteins accumulate to further reduce the circuit's electrical excitability. By deleting its own receptors to survive the relentless digital flood, your brain accidentally makes itself numb. It becomes chemically deaf to normal, everyday levels of stimulation, leaving you completely unmotivated to do anything that doesn't provide an immediate, extreme reward. This structural numbness makes perfect sense when you look at how the brain processes opposing sensations. Pleasure and pain are co-located in the same subcortical brain structures. They operate like opposite sides of a biological seesaw, and that seesaw always seeks to remain perfectly level with the ground. Every time cheap digital stimuli tilt your balance toward pleasure, your body reacts with neuroadaptation. It automatically drops chemical counterweights onto the pain side of the seesaw to force it back to level. This is the biological come down, that slight irritability you feel the second you close an app. But if you chronically overconsume those quick hits of pleasure, the regulatory response gets stuck. The chemical counterweights on the pain side multiply and refuse to leave. No matter what you do, the seesaw is now permanently tilted downward into pain. You have now entered a chronic dopamine deficit state. Because your receptors are closed off and the seesaw is weighed down,
your baseline psychological state shifts into persistent anxiety, irritability, and crushing mental fatigue. This explains the trap of modern distraction. At a certain point, you aren't opening a social media app because it feels good. You are no longer chasing a high. You are compulsively scrolling just to temporarily lift the heavy weight off the pain side of the balance, desperately trying to feel normal.
Because the reward circuit has physically mutated its own cellular structure to defend against overstimulation, you cannot fix a broken focus with time management tricks. You cannot schedule, optimize, or multitask your way out of a dopamine deficit. To repair the circuitry, you have to use the pleasure-pain balance in reverse. The biological cure is a process called hormesis, intentionally leaning into friction, discomfort, and right-sized physical pain. When you subject your body to deliberate, controlled stress, like strenuous aerobic exercise, intense weight training, or submerging yourself in freezing water, your brain interprets the extreme cold or physical strain as a direct threat to its survival. In response to this threat, the brain triggers a powerful internal healing mechanism. To help you endure the stress, it initiates a gradual, sustained release of endogenous neurotransmitters, including a slow, steady wave of healthy tonic dopamine. Because you earned this dopamine by paying for it up front with physical effort, it doesn't cause a toxic spike or a crash. Instead, this natural wave slowly coaxes your neurons to reopen. Over time, it rebuilds your D2 receptors and restores your baseline capacity for deep, sustained focus. The motivation to do meaningful work is not a spontaneous feeling you can sit around waiting for. It is a precise neurochemical state that you have to actively generate. In an ecosystem heavily engineered for cheap sedation, intentionally choosing to do hard things is the ultimate biological rebellion.